Let's look at quadratic equations that have rational roots. In other words, roots of their fractions. 1/2, 2/3, -3/4, things like that. So let's just look at the graph of something. Let's say it has roots of -3/2 and +5/2. So at -3/2 and +5/2 are our two spots where our function is equal to 0. So if we think about that, there's something that we have to add to -3/2 to turn one of our factors into 0. Something we have to add to +5/2 to turn our factor into 0, so when we multiply our factors we get a product of 0. So first let's look at if x is equal to -3/2, what would happen? Now I'm going to solve this for x so I get 0. So I'd have to multiply both sides by 2 and then add 3. So I would end up with a factor of 2x plus 3. And for our other one, if x is equal to 5/2, again I'm going to multiply by 2 and then subtract 5. And get that equal to 0. So these would actually become our factors. 2x plus 3 and 2x minus 5. Now I could go ahead and multiply these out. 2x times 2x is 4x. 2x times -5 minus 10x. 3 times 2x is 6x. 3 times -5, -15. Add my like terms. This should have been 4x squared, excuse me. I have 4x squared minus 4x minus 15, which would be our quadratic equation for a parabola that had roots of -3/2 and +5/2. Now, notice with these factors and roots that this number ended up here with the opposite sign. This number ended up here with the opposite sign. And this ended up here, and this ended up here, which is a property that can kind of be a shortcut in the future when you go to deal with quadratic equations of this type.